guys, welcome back to In Case of Econ Struggles. Today I'm going to talk to you guys about how to estimate nonlinear least squares functions in Stata, especially when you're writing your own command with the nonlinear estimator in Stata. Okay, a lot of credit for this tip and the things I'm going to show you in this video come from Isabel Canet on the Stata blog. So that was really helpful when I was doing my own research and trying to work on writing my own nonlinear least squares program. So I'm going to use what I learned to talk to you guys about that today. So first, what we're going to do is suppose that I'm using this web use production data, which is basically just going to have three variables in it. It's going to have capital, labor, and the natural log of output. So maybe what I'm trying to do is I'm trying to estimate a Cobb-Douglas production function, trying to estimate the parameters of that Cobb-Douglas production function using these three variables. Now, of course, because it's nonlinear, I can't necessarily use an OLS or a regular regression in order to figure out what those parameters are. So I'm going to have to turn to a nonlinear least squares estimator. Now there is a way that I could do this where I don't need to write my own program. However, I generally find that being able to write my own program makes it a little more flexible. It's easier for me to track and it's sort of just a little cleaner. It's also helpful if I want to run this sort of program multiple different times. I only have to write it once, can save it as a .ado file, and then call it sort of in any other program I need. So just to start, let's go ahead and just type in help nonlinear just to see what we've got in the help file. So I'll go ahead and open this up. And so what you're going to see is that you can see there's a bunch of different options. There's a way to do this in the command window, but we're going to focus on this function evaluator program where we're going to write our own program. Okay, and so the way we're going to write our own program is going to be sort of buried in this help file, and so that's what this video is for. So what we're going to do is just sort of get into it. So let's go ahead and start by program dropping or cat dropping the name of our program. I'm going to call this program NLCES2. And what I need to do when I name the program for a nonlinear least squares estimator in Stata, the first two letters have to be NL. So what Stata is going to see is that if it sees the program starts with NL, it's going to say, okay, this is a nonlinear program function evaluator. This is the actual name of my program, CES2. And so that's what I'm just going to call it. The version of Stata that I'm going to pin this program to is version 12. That worked the best for me working on Stata 17. If you're running Stata 18 or Stata 19, you could probably bump this up to 17 or 18. But for me, 12 worked the best. Okay, now what we're going to say is we're going to say, okay, this program is going to have some syntax to it. And so what I'm going to do is I'm going to give Stata a list of variables. And I'm going to say that these variables are exactly equal to 3. So I'm going to give it 3 variables. Again, based on your program, you might change the number of variables that you need to have. This if statement is required by Stata, so you need to have this in here. And then at and just the name of your initial matrix or where you're going to start. Okay, and that'll become important when we do the actual estimation. Okay, so now we're going to move on, and now we're basically going to say, okay, well, I'm going to give Stata a list of variables, and I want to be able to call specific variables in my program. So what I'm going to say is I'm going to say, okay, I'm going to call log out the first word of this var list enclosed in these single quotes, just like a local. Capital is word 2, and labor is word 3. Now notice what this means is you always have to give the program your variables in this order. So for example, if your var list was like capital, labor, log output, okay, you put capital first, so it's going to treat the capital variable as the log out variable. So you just have to be careful in terms of your order. The order of the variables you give to Stata is going to matter for this command. Now that we have our words in here, we're going to go ahead and get some parameters out of this matrix. And basically what we're saying is there are some parameters that we want to estimate in this production function. We have a constant, which I'm calling B0, which is going to be the first parameter that I give it when I run this command. Rho is going to basically be the productivity parameter in this production function. My last parameter is going to be delta, because what I'm going to say is this is going to be a constant returns to scale production function. So if I know delta, which is going to be the coefficient or the exponent on capital, then 1 minus delta is going to be the exponent on labor. Okay, so now that I have these parameters, the next thing I'm going to do is can generate any variables that I'm going to use to basically help make the code simpler. So for this example, I'm going to have a capital term and a labor term. So the capital term is going to be delta times capital raised to the negative rho. Again, I need this if I'm going to generate doubles. And same thing for the labor term, where instead of delta, it's going to be 1 minus delta. And then I'm going to replace the log output variable, which is that variable or that word, the first word of our var list we said earlier. This is going to be our constant. This is going to be minus 1 over rho times the natural log of our k term, which I defined up here. plus our L term, which I defined right here. So this is a log linear function version of this production function. And so now we've got our program in hand, so I'm just going to run that all together. And then I'll read back in our data. Now one thing that Stata does not like when you run this nonlinear least squares is that there can't be any missing variables that you use within any particular row. So just like with a regression, if you run a regression with multiple variables, Stata automatically kicks out observations where you have missing for one or more of those variables in your regression. The nonlinear estimator won't do that for you. You have to make sure that you're only giving it observations where that is true, where you have non-missing values for all the variables. If you don't do that, the nonlinear estimator just will stop and say, nope, you've got missing values for some of these variables. I'm not going to do this estimation for you. So you have to generate sort of a new variable to tell Stata which observations you want to include or not. The way I generally do that is I just generate some new variable called use, which is just going to be a 1 if my 3 variables are not missing for any particular row. And that way, if it's missing for output or capital or labor, it's going to turn this into a 0. And then I can use this with an if statement to make sure that I'm only using rows that have non-missing values for each variable. So now what we're going to do before we run sort of our full nonlinear estimator, I like to go ahead and make a test to say, okay, when I generate these doubles, am I getting missing variables for anything? Is something going wrong? Or does it seem like everything is generally going as I expected to? So first I'm going to generate this matrix, and I'm just going to call this matrix M. And this is going to be my initial matrix for the test, where I'm going to start by saying that B0 or the constant is 0. Maybe that row is 1, and maybe the delta is 0.5. And then what I'm going to do is I'm going to generate a new variable, which is a copy of the dependent variable I want to use. The reason I do that is because when I run this test, Stata is going to replace this variable, whichever variable I use as the dependent variable, with this line here based on the starting values. And if I don't generate a new variable, then when I go to do the full nonlinear estimation, I'm going to be using this replaced dependent variable rather than my original dependent variable. So let me show you what I mean. So I've generated this new output new equals Ln output. So if I browse, you can see that I've got an exact copy. Now if I run this test and I go ahead into browse, what you're going to see is now I've changed this variable from before because it's just run the test. It's run one iteration of this loop. So it hasn't done multiple iterations where it's tried to predict this dependent variable as closely as possible by changing B0 row and delta. Instead, it's just run it once with the starting values. And so that's what's reflected in this NL output new. And again, I don't want to overwrite this output when I'm testing, which is why I created a new variable. So now that that worked, I am going to go ahead and run my full nonlinear estimation. And you can see that now I am iterating over multiple times to try and reduce this residual sum of squared error. And you can see that now I have estimates for my beta 0, my rho, and my delta, which all looks good. Okay, so again, I could have done this in a different way where I just sort of wrote it in the do file in one line. I think it's easier or more helpful to get used to writing these programs because if you're trying to estimate a more complicated non-linear least squares function, well, if you know how to write the program for the simpler version, hopefully when you go to write a more complicated version, you're just scaling it up and you sort of already know what's supposed to happen and how it's supposed to work. So again, in the help file, they talk about this exact example, just going through it as a video format. If you got a specific issue with nonlinear least squares estimation, you can't figure out something's going wrong in your code, feel free to put that in the comment section below. Also, let me know if this video or these videos in general are helping you out. We'll see you next time for another case of econ struggles.